I'm Emanuele Bellini from University of Florence, and I'm the coordinator together with Paolo Nesi of this project, European project. This project is funded under the DRS7, is a specific call dedicated to the resilience and to how to manage resilience in the society. We focus on transport system as a critical infrastructure, so just to be aligned with what the call asks to us, and one of the major outcomes of the project is to implement the European guidelines, because the European guidelines is a document of 2011, so it needs to be improved, needs to be aligned with the last breakthroughs and the best practice. So this is our consortium, and I think it's well balanced, and you can see digital decision makers like Florence City Council and Attico Metro is the critical infrastructure managers for the metro in Athens. We have two industries, large industries like Thales and Svarco. Everybody knows Thales. Svarco is one of the leader in Europe for the traffic management system. Two partners that are main focus on resilience, Milano Ricerche and a Portuguese university. And CERT is a Greek research institutions that are more oriented to transport system. The dissemination is dealt with by the Humanist network that group together some experts from different disciplines and with a focus on resilience from Fraunhofer, and our laboratory, the DZIT lab, that we have strong backgrounds in data mining and smart cities. In particular, we are software engineers, okay? So we basically are coming from engineering department, information department. And we work with data, usually big data now, so collecting information from heterogeneous sources that range from open data to sensor data to human behaviors data generated by human movement on the city, tracking their behaviors through smartphone and the like. So we implement such competencies and technologies, but this is only a means, not at the end, okay? So let's see how we can use data for resilience. This is the 5 objects for our project. I would like to focus on the objective number 3 and 4 because this project is started in May, so we have not much to present now, so we have not already released the guidelines, but we have some ready for the tools that we are going to use. I would like to show this slide because in some sense is aligned of what we said in these 2 days. The first one is to use theory. Okay, so we decided to adopt the FRAM, the resilience engineering approach. Why? Because these competencies were bring into the consortium by the Portuguese partner. But the idea is to follow an holistic approach. The second is related to the stakeholders' engagement. Okay, so since we are going to produce guidelines, we cannot close in our tower and then at the end push the world to adopt what we said. Okay, so the idea is to implement a truly consensus-driven process involving as much as possible all stakeholders that could bring added value in the guidelines implementation. Even if we are involved with them, they are more willing to accept and to adopt the guidelines. Okay, so this is sort of a win-win approach. Then the guidelines should be translated to concrete tools, because otherwise guidelines remain a document that everybody read and then nobody implement. Okay, this is very common, so we have tons of examples. The world is full of guidelines, okay, for everything. But it's very simple. Yeah, but let's say just an example is for ISO. There are a lot of ISO standards, but not all of them are really implemented or are tools to implement it. So the idea is implement guidelines and then adopt the tools, technological tools to operationalize in the real setting. So we have two pilots, one in Athens, one in Florence. Here I would like to focus only the Florence pilot, and in particular the flooding event. We have had bad events in the past, in 1966, and you can see probably most of you knows what's happened. And I would like to remark some elements that are useful for understanding why we are very interested in this project. Because in the 1966, the most interesting things that I would like to notice is this one. 15 hours has passed from the first signals, so the first victim, up to the waters flooding in the downtown of Florence. 15 hours. This means that what's failed? A lot of things. Failed the early warning systems that in the past was not really implemented. There are not strong protocols. Failed the risk perception of the engineers that undervalued the risk and not advise the citizen. In fact, the 19% of the population were completely unaware of what's going to happen. This is really, really interesting. So nobody believed that something of what actually is happened could be happens there. So this is another thing that the risk assessment, the documents that explain the risk, the maps of the risk was already there. So the difference here is that, okay, I have a document that describes all the risk, the level of the water, the in case, and blah, blah. But a part of the documents, you need to bridge the gap between documents and the real implementation. Okay. This is another interesting event that was happened during these days. Here you can see this is a risk map, okay, of the hydrogeological risk in Florence, and the lighter part was describing the level of the water respect to big events as was happened in the 1966. So you can see here that if the people remains here, they will be saved, okay? But nobody were aware about the context, okay? So nobody were that. So they receive information from friends, for colleagues, that something are going to happen, and is happening here. Okay, so they decided to escape from the hazard, so move far away from the river. It's quite logical. Okay, instead the water arrive from this direction because the ground has a specific shape. So the result was victims here. This is classical, typical situation in which communication, information, data, and blah blah and the like will useful to prevent such type of critical things. And of course, what's lack of community preparedness, of course, because nobody were aware about the state of their place and the case in which if they stay there, they will be saved. The contextual and real-time information. So knowing if the waters arrived in different direction could be saving more life. lack of wrong official early warnings. Nobody was warned about that, and they exchange, the citizens exchange information through peer-to-peer, so with the telephone, okay, basically. So the information shared are not really trustable, let's say, because people talk about what they see. But if I see something and I live here, I see something different, and I communicate a specific risk to the people that live here, but it's not what they need to know if they live here, okay? And another thing was a questionable allocation of the resources. So, 5 minutes. Oh my God. Okay, okay. Let's to speed up the process. Okay. And very interesting things happen during the events. The Moon's Angels. So a lot of volunteers goes to the historical buildings and trying to save his books, trying to save masterpieces without any rewardables apart of the would like to be helpful for the others. So Florence wants to reinforce collaboration among city actors, of course, clarifying responsibilities and rules. This is really important because nobody knows who is the responsibility about if the water rise up under the underpasses in Florence right now, because it depends of what pass over the bridge. If the train is the train of the bridge, the responsibility of the underpass is by train company. If it pass a street, the responsibility is for city council. If it pass another thing, the responsibility is for other things. So you have a lot of underpasses that could be flooded, and nobody knows who will act there. This is nice, another interesting thing. Improving interdependency understanding, managing resources available, and so forth. So why we like the quantification, or we like to having something of real a part of the models, a part of the theory, because we are expert in big data management, of course. And in Florence, we have a very nice and unique examples of data availability. So we are able to collect the traffic data flows, public mobility service in real time. We have the hydrological risk map in open data, so you can download it in a shape file and you can explore. We have the Wi-Fi that covers the 80% of the cities and the like. We also have the cadastral data connected to the data. So we are able to know in each time, in real time, where the people are, where are the concentration, where the public service, how the public service works, and so forth. This is an example of tools. It's quite chaotic, I know, but it means that there are tons of tools that are already in place, and you can test it, download it, are open source, so they are open. This is the example of sort of cockpit dashboard that we are going to release to the decision makers, to city councils, in order to decide what to do during the emergency and for planning phase. Okay, so through the simulation, we are able to collect the Twitter. So through the Twitter, we are able to detect very, very quickly if something happens. So if the Twitter was in the 1966, was able to detect the events after 5 seconds, 10 seconds, 1 minute, okay, and then react properly. Other tools here, we already mapped all the services that are in the city, all the services, so business service, public service. We have more than 20,000 service map georeferenced here. So we exactly know if something happens in the specific area, we exactly know which could be the effect, or which are the services that will be stopped, which are the services will be affected, or the cost of the damage. And also all this data will be combined together through an ontology. This is really important. Not having tons of data within a unique receipt, but having an ontology. Ontology means that we have an idea of how the city works, which are the entities, which are the relationship, and something like that. So in this sense, thanks to the ontology, we are able to retrieve information through semantic queries. This is just, okay, 1 minute. This is our approach. We use FRAM, and this is very important. FRAM is up to now is a model so we are able to design the interaction of the functions in the city. But since we have data, we need to reconnect the model to the data. Okay, so that only with this approach we are able to quantify, measure, or something. Okay, I stop it.
Thank you. Are there any strategies in place or ideas about how lessons learned from this particular case could be applied to other cities and how you could sort of scale up doing some of these things in other places?
Yes, actually, the strategy is engaging, well, it's not a real business sustainability now, up to now, but these technology are floating in a spin-off of the university. This means that we still keep the technology available for everybody as open source for public interaction. But in case you want to buy added value services and the like, we are able to sustain the solutions with a business model. But is a process ongoing. Okay, it's not already decided. But yes, is an issue.
Yeah. And that'll be it, I'm afraid. Okay, just what you've described is fascinating, but it strikes me as it's very, very similar to emergency management using big data. So what's, in your conception of the project, what's distinctly resilient or resilience about it?
Exactly, is more close to the emergency system, but thanks to the data, okay, you can improve some parts of the socio-technical system as the city is. This is an example. We would like to train the citizen through a game in sort of to improve their preparedness for specific events. And through the data, we are able to monitor and evaluate if the train works or not. It's a bit different with respect to, okay, I disseminate brochure, rules, guidelines. I am able to monitor the interaction of the games, of the user, of the citizen, and through their performance, I'm able to know if my project, my program is acceptable, is workable, and the like. So game is a strategy, and we know that it works because there are a lot of...
Yeah, thank you very much.